Here are a couple of trig functions composed with inverse trig functions. The first problem says sine inverse of sine of 210 degrees. Calculate it. So remember that fundamentally trig functions have to do with triangles. So as much as you can, force yourself to think about what is happening here. Now sine takes in an angle, in this case 210 degrees, and it outputs, you can think of it as either outputting the height of the end point on the unit circle. If you had a unit circle here, the height would be negative 1/2, or you can think of it as outputting the opposite side over the hypotenuse. So if this side was, if the hypotenuse was 1, this side would be, say, negative 1/2. Okay? Now, so this inside piece is equal to negative 1/2. Now you can write that in, but you don't have to actually when you're composing sine inverse of sine, because what happens is sine inverse takes in the opposite side on the unit circle and outputs the angle in the first or fourth quadrants. So it outputs an angle between negative 90 degrees and 90 degrees, okay, because we're working in degrees. So what angle between negative 90 degrees and 90 degrees returns negative 1/2? Well, if you make just a parallel line across, you'll see that that angle is negative 30 degrees. Right? So this is negative 30 degrees. So the effect is, if an angle goes into a sine and comes out of a sine inverse, everything here will stay in the first and fourth quadrant. But things here go to their height, and then they somehow flip over into the first and the fourth quadrant. So see, 210 degrees becomes negative 30 degrees, 150 degrees would become 30 degrees, and so on. This problem is a little different because the inside is an inverse trig function, but I'm still going to draw a triangle. Now, cosine inverse takes in, well, cosine outputs adjacent over hypotenuse, so cosine inverse takes in adjacent over hypotenuse. Now, remember, cosine inverse only considers these two quadrants, first and second quadrant. So I'm going to draw a triangle here. Maybe I should draw it a little higher because my adjacent side has to be negative 1 and my hypotenuse has to be 4. That way, cosine of this angle, we could call it theta, is negative 1/4. So this inside piece is equal to theta. I don't have to know what theta is to then calculate sine of theta. Sine of theta asks what is the opposite over the hypotenuse. Well, I need to know what the opposite side is. Luckily, I have the Pythagorean theorem that says 4 squared equals this side, y squared, plus negative 1 squared. So that's 16 equals y squared plus 1. Subtracting 1 from both sides, y squared equals 15. Notice that since I'm in the second quadrant, y is going to be positive. So I'll just write root 15 there. So what is sine of this angle? Well, it's root 15 opposite over hypotenuse.